In question 7, we've been given a triangle TQR, which represents 3 points on a horizontal plane, which basically means it's on the floor. Triangle TQR is on the floor or on a flat plane. And we've got a flagpole PQ, and that will form a 90-degree angle with the floor, as they did illustrate for us. All the information they supplied over there is on the diagram, quite luckily. And now we need to express theta in terms of alpha and show that sine of theta is equal to sine of 2 alpha. Now to do that, we need to work in the triangle that has theta as well as alpha, and that's the bottom triangle TQR. We can see a theta there and an alpha there, so we're going to ignore the other triangle for a second. And if we're in triangle TQR, you might notice that this length TR is the same as this length TQ, because they both denoted with a variable y, so they must have like the same value. If y was 10, both of these sides would be 10. So we're actually working in an isosceles triangle, and I like to mark it off on my sketch like this. And after I marked it off, a little bit of Euclidean has entered into the picture. Okay, now what do we know about isosceles triangles? The opposite angles are equal, so this over here will be the same as this angle here, alpha. And this is the Euclidean theorem that dictates that angles opposite equal sides. You're not expected to give reasons within trigonometry, so we're safe not to give a reason over here. So now we know that all the angles inside of a triangle add up to 180. So let's formulate an equation that says that. And how we formulate that is this angle plus this angle plus this angle all equals 180. Right, now I need to express theta in terms of alpha. What that means is get theta on its own. So let's go ahead and start doing that. Alpha plus alpha is just 2 alpha. 1 apple plus 1 apple is 2 apples, my bro. And then to get theta on its own, I'm just going to move that 2 alpha to the other side, and it becomes minus 2 alpha. And now the first bit of the question is done. Express theta in terms of alpha. Done. Theta equals 180 minus 2 alpha. And now we need to show that sine theta is equal to sine of 2 alpha. So it almost looks like this, but I'm missing sines. So what I do is introduce sine on both sides of the equation like this. So in front of this theta, I just put a sine, and in front of this, I put a sine, but just make sure to wrap it in brackets. Now over here, I see a 180 minus. The alarm bells are ringing for reduction. So let's grab a cast diagram and do that quickly. And we are in the 180 minus quadrant. In the 180 minus quadrant, sine is positive. So this is just going to change into sine of 2 alpha. And we've arrived at the finish line. Sine theta equals sine of 2 alpha is exactly what they asked us to prove. Yes, you had to fight hard for these 2 marks. Alright, so this line over here, sum of the angles inside of a triangle gets you your first mark. And your second mark will come from sining both sides, if that makes sense, introducing sine on both sides. You don't get a mark for this because they gave that to you. And 7.2 says hence. When I see this word hence, hey baba, you gotta look at your last answer. They're telling you, use this to help you, Chana Bean. Prove that in triangle PQR. Alright, let's get rid of the other triangle. We're only working in PQR now. We need to prove that PR is equal to this trig expression. So PR forms the hypotenuse of our triangle, and we are working in a 90-degree triangle. We're on the nice side of town, bro. In a 90-degree triangle, we've got 2 tools at our disposal. We have the very infamous Pythagoras, as well as the classic SOHCAHTOA. Right, we only use Pythag when we've got 2 sides and we're missing a third, so we're not going to be using Pythag. So we are using the infamous SOHCAHTOA. Alright, so I want the hypotenuse. I want to get PR, so we've got to do something with hypotenuse. So it's either going to be sine or cos. And we also want to tie in the information we have. So we've got to use this x somehow. And x is the adjacent to my angle. It's adjacent or next to this theta. So we will be using cos because we have the adjacent and we want the hypotenuse. Okay, so this is already our angle theta. The adjacent side is just x, so we fill in x there. And the hypotenuse of our triangle is PR, so we just fill in PR there. Now I want to get PR on its own, so I can literally just swap it with cos theta. It's a shortcut of cross multiplying. I'll show you the long way quickly in case you are interested. So you put cos theta over 1 like this, and then you multiply going up. So I bring this 1 up, 1 times x is just x, and I bring this PR up, PR times cos theta is just PR cos theta. And then from here you divide both sides by cos theta to get PR by itself. And then these causes cancel as we planned for, and x over cos theta cannot be simplified, so there you have it. And a shortcut of doing all of that is this. You literally just swap the positions of cos theta and PR to get there. So you do want to get comfortably enough to make that adjustment. Okay, now this is, it's not quite looking like that, but it's got some aspects we want. It's got a cos theta at the bottom. This one has a cos theta at the bottom. So we need to transform this x into this trig expression using the other triangle. So now we divert our attention to triangle TQR, and we want to get an expression for x that mimics this format. So we're going to ignore triangle PQR and work with triangle TQR. Okay, now that we're in triangle TQR, we are in the cuck side of town. There's no 90-degree angle, which makes our job significantly harder. If there's no 90-degree triangle, there's 3 rules or formulas that you can apply. I'm going to show them on the screen now. They are called the sine rule, the cosine rule, as well as the area rule. Okay, and we need to get an expression for x. My first instinct is to always use the sine rule. I don't like using the cos rule and the area rule. I only use them under these circumstances or if they ask me for the area. So we are going to be using the sine rule because we've got enough information. We know all the angles here, and we know all the sides of this triangle, so we've got enough information to actually choose which rule we want to use, and the sine rule is the simplest. So I'm going to get rid of the other 2 rules, and I'm going to walk you through how to use this thing. Now on the formula sheet you get given all 3 of these. We only use 2 at a time, so I'm going to get rid of this. And on the top here we need to put in the sides of the triangle. So we need x, we need to change this x to 2y cos of a. So I'm going to change this to x, and then at the bottom must be the angle opposite it. So at the bottom will be sine theta. And inside of this side an angle, I'll just choose another one. I can choose this one or this one. It'll lead to the exact same outcome. So I'm going to change this side to a y, and then opposite that y is alpha. So it's going to be y over sine of alpha. And now I've successfully implemented the sine rule. Alright, so the mission is to get x on its own here so that I can put it in there and hopefully get this. So I'm going to move the sine a to the top on this side. I'm going to basically cross multiply, but only with one of them. And I did make a small mistake there. This should be theta because x is across from theta. Sorry about that. Takes that sine theta up, and then we've got y sine theta over sine alpha. Now this word becomes important, hence. So this sine of theta here, I'm going to change it to sine of 2 alpha. And I knew to do that because of the word hence. Hence means use your previous answer to help you. I was getting quite stuck here. I didn't know what to do. So if I look at hence, I can change sine theta to sine 2 alpha. And now there's a double angle, my bro. 2 times alpha, you're doubling the angle. So let's grab the double angles quickly. And quite thankfully for sine of 2 theta or 2 alpha, there's only one double angle that's applicable. It's the last one. Alrighty, we are making some progress. We changed that sine of 2 alpha into 2 sine alpha cos alpha using this double angle formula that is on your formula sheet. And now we have a 1 term over 1 term, so we can cancel the sine of alpha and this sine of alpha. The sine of alpha. They get out of here, bro. After we cancel these sines, then 2 times y is just 2y, and we glue that cos alpha on there. And now finally we can change this x to 2y cos of alpha. And we have finally proved what they asked us to prove. PR is equal to 2y cos alpha over cos theta. PR equals 2y cos alpha over cos theta. Sure, quite a nasty little one. So this was the nice side of town, the 90-degree triangle. This was the ugly side of town where we had to use the sine rule. You get 1 mark a pop for using cos as well as the sine rule. Expanding the double angle as well as the cancellations of sine alpha to simplify. Then your final answer does not get a mark because it is given to you. In question 7.3, they've asked us to calculate the area of triangle TQR, and they've given us the following information. So I'm going to get rid of the other triangle. Let's just focus on triangle TQR. And additionally, I'm going to get rid of alpha, x, and y and replace them with the actual numbers that they supply to us. And I'm tempted to use area equals half base times perpendicular height, but I don't see a perpendicular height. So it's going to force us to use the area rule. So let's grab the area rule quickly. Okay, so with the area rule, there's a small term and condition that you've got to adhere to. If you're going to use the area rule, you've got to use 2 sides and the included angle. So I'm going to go to the angle I know, and then I have to use the 2 sides that are next to the angle. So I'm going to have to use the 15 and 20, and I'm literally just going to sub it in here. Okay, so when I sub in the sides A and B, it can be in any order, because you're multiplying everything in this formula, and the order of multiplication doesn't matter. So I'll just put the 15 first and the 20 second. And then inside of the sine, I've got to put the angle in between those 2 sides, which is 49 degrees. And once you've subbed that in, you pop that straight in your calculator. And if we press equals, we get 113,21. And bear in mind, we are working in meters here, and area will be meters squared because it's 2 dimensions. And having a look at your 3 marks, 2 marks purely come from substituting into the correct formula, and the last mark comes from the correct area with the correct unit.